Okay, so here we go. Mel's helping me out with this one, I guess. She's decided to stay here. Let's see how long she can do that. She might need to get kicked out. This section, we actually are going to do some problems out of Mr. Honigs' book, as you can see right here. It's his totally legit book that he wrote, and so we're just going to use it. Oh, she doesn't like teacher voice. So here we go. Um, So first thing that we're going to talk a little bit about is intercepts. So X and Y intercepts. So our Y intercepts we talked about last time. And that's if you cross the Y-axis, you can write it as a coordinate point, 0b. X-intercepts are the opposite, it's A0. If you are looking at a quadratic, fun fact, that last letter, C, is the intercept for that quadratic. So if it's in factored form, the very last number is the y-intercept. So, fun fact. Reminder, you don't need to write down this whole thing. I've got the textbook part of Honigs posted on our Schoology site. So you are just gonna, whoa, hey, I need a pen. You're just gonna worry about that part right there. So that's all you have to write other than the problem. Well, not even the problem, it's just 15 to 17. So you don't even need to write the problem down, just like what I write is all you need to take care of. So we want to find the x-intercepts. To find the x-intercepts, not the y-intercepts, we have to factor this thing. So we'll set it equal to 0 and factor by replacing y with 0. So I'm going to make that a 0 equals, whoop, and then the rest we're going to factor. So we need something that multiplies to be 35 and adds to be 12. You might be thinking, oh, I know what that is. It's 7 and 5. X plus and x plus, kind of looks like a y. Oh gosh, that's horrible. That's fine. Now, we need to figure out what our zeros are, our solution. So what is going to make each one of those parentheses a 0? So the first one, -7 makes that thing a 0. The other one, -5, that makes it a 0. Done. This next one, if you wouldn't mind moving, friend. Hey, whoa, I didn't know I could do that. It's not at all what I wanted to do. I just want to take this guy and I'll move him to the side. There we go. This one, sure, we have f of x, but that works just the same as a y. So we got 0. I want this to be purple. And I need to factor this thing. Now this one is a little bit more complicated because there's a bunch of like numbers going on. What I want to factor out first is I'm just going to factor out a 2. Just to make all the numbers a little bit easier to deal with. So then we got 7 squared plus 6x minus 1. And we're going to use what we did before and a little bit backwards, since now we've got the 1 here instead of there. In this one, we had the 1 at the beginning and a number at the end. We're going to use that same idea. We want something that multiplies to be 7 and subtracts to be 6. Well, 7 and 1. So we've got 0 equals 2. We're going to keep it with the x. And on the end, we want two things that multiply to be 1, so 1. Now we want this to end up with a positive 6. So we want to make sure that the 7 gets the plus. See, these two are going to multiply together to become positive 7. And then we're going to subtract one of our x's when we foil to get that positive 6. Now we want the things that make those two parentheses equal to 0. The first one's easy, x equals -1, done. The second one's a little trickier. You have to add a 1 to both sides and then divide by 7. So x equals 1/7. Final one, set this thing equal to 0. And we've got a factor. Now this is my favorite type of factoring. This is a difference of squares. We've got two things with a subtraction in the middle. So they're going to be identical. So we got x and x. We've got two things that multiply to be 81 is 9 and 9. One of them is going to be positive. One of them is going to be negative. That is a hideous 9. That's a little better. Two things that multiply to be 8 is to be 64 is 8 and 8. Oh, it's been a long summer. Um, so now the two things that are going to get this thing equal to 0, we're going to get a little plus or minus action because they're both going to be the same number, just one of them is going to be positive, the other one's going to be negative. We would subtract or add 9 to both sides and then divide by 8. So x is positive or negative 9/8. Yeah, that's it for that. When you're factoring, some of the things to look for, you want to take care of your GCFs first. As you saw in that previous example, I got rid of that 2 before I did much of anything else. Look for those difference of squares. Sum or difference of cubes is something that we kind of skipped over, but you do want to make sure you know how to do those. Those are listed right down here. So if you have a sum of cubes, you always get like a term that looks like the same thing, positive, positive, negative, negative. And then you end up with a trinomial on the end. This is going to be the opposite of whatever you had. So if you have a plus, it's now a minus. If you have a minus, it's now a plus. Square the thingies and then multiply the two terms together. So now we're going to do a couple more examples out of the Book of Honigs. Reminder, we're just going to write H. There's no pages because it's just one page and 1. So when we're solving these things, once again, the long version of it is that we're saying, okay, well, x minus 4 equals 0, or x plus 3.5 equals 0. And then you're solving those two equations. So x equals 4, or x equals negative 3.5. Now, we don't want to necessarily be writing all that out every time. We want to just be able to solve these in our heads. We've got a lot more things going on that we don't have the time to actually like write all these equations out. Calculus is about speed as well as accuracy. So there's certain things that we just don't have time for, and we really don't want to waste our time doing it. So what I just did, that was no good. We want to just be able to solve that in our head. Oh, x is 4, x is negative 3.5. Looking at this next example, you would just say, oh yeah, z is 8/3 and z is negative 4/7. You should be at the point where you can solve a little two-step equation like that in your head. Next, we're going to do a little bit more practice with greatest common factor. That's one of the things that's most quickly forgotten, but it's one of the most important things because if you can factor out your GCFs, it makes a lot of your other factorings a lot easier. So it's important that you know how to do these ones. So what you're looking for with that 7 and the 9 is you're saying, okay, well, what factors of 7 or 9 match up, and what's the biggest one? 7's prime, so it doesn't have any factors that we can pull out other than 7 and 1, and 9 isn't divisible by 7. So in terms of numbers, we can't really take anything out. What we can take out is whatever the smallest exponent is that they have in common. So we have an x to the 4 and an x to the 5. So we can take out an x to the 4. That is our GCF. Plus 9 to the 9x. We can do the same thing in this next one, but there's more things going on. First, we got that 7 and we got that 21. Well, hey, take a look at that 7 and check its factors. Don't bother with 21. It's going to have a bunch of factors that are going to be bigger than 7. So we don't really want to check those. 7's going to have a smaller list that you can check against 21. So its only factors are 1 and 7 again. So 21 is divisible by 7. Sweet. So that's going to be part of the factor that we pull out. We also have a couple y's. So the smaller exponent is y cubed. And we have some x's, which is x to the 6. Wait, no, we want the smaller one, 2. So now we divide all of our stuff. So 7 divided by 7, that's gonzo. Y to the 4th divided by y cubed is left with just a y. X to the 6th divided by x squared is left with an x to the 4. I'm just subtracting those exponents. Plus 3, x squared divided by itself is 1, so gone. y cubed divided by itself is gone, 1. Now this next one, you might have seen this big note up here, is it's got a y prime. Y prime, that little tick mark on the top of it. Y prime is something that we're going to be doing a lot. If you've ever heard of derivatives, we represent them a lot of the times with this y prime idea. More about derivatives when we get into the proper calculus material. This is just review. What we're going to do is we're going to factor out that y prime as if it were a GCF. So we're going to factor it out as if it were a z or something. So I checked the 18 and the 14. Let's see, we've got 7. Nope. 2. 2 is our only common factor. So we're going to factor out a 2. Oh, got the wrong tool. We're going to factor out a 2. In terms of w, the smaller exponent is cubed. With the y's, the smaller exponent is 1, and we do have that y prime. So we can factor it out. They both have a y prime, so we're going to take it from both of them. So we get 9w to the 5th divided by w cubed gets us w squared, and a y minus 7. W cubes go away, the y's go away. Yeah, so here it's just 7. So I can probably cram it up there. Done. All right. Again, we're going to do some more equation solving. At this point, hopefully we're okay with what's going on. You know, you factor out your stuff. Oh. And then set them equal to 0. So what makes x 0? Well, 0. What makes x 0 in the other one? Well, negative 10/3. One thing you do have to watch out for is if there is not equal to 0, you need to make that thing equal to 0. So in this second example where it's not equal to 0, like the first one was, we have to get that 4x onto the same side, like this, and then factor. So we can pull out a 4x, got an x minus 1. And then we can get our two zeros. In the first one, 4 times what is 0? 0. And then what minus 1 is 0, 1. That's all set. I think we got a couple more. So in this one, we're going to do that solving thing again, but rather than trying to solve and figure out exactly what that thing is, we're going to solve for this y prime thing. That's something that we're going to do in calculus, so we're just going to practice a little bit. We don't really know why we're doing that one, but we're just going to do it for funsies. So all I'm going to factor out on that left-hand side is that y prime, nothing else. So I'm just going to take out y prime. And we're going to leave everything else in there. So 15x cubed, make that look a little bit closer to an x, y squared, minus 14x squared and y equals all that garbage. I ain't got time. Then we want to try to get y prime by itself. But since we factored it out, we can just divide by all of this stuff, this 15 y cubed y squared minus 14 x squared y. Pretty neat. So we get y prime equals negative 15 x squared y cubed plus 14 x squared y squared all over 15 x cubed y squared minus 14 x squared y. Now you might be tempted, ooh, I'm going to cancel those 15s, I'm going to cancel those 14s, I'm going to cancel x's left and right. No, 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 no. You can only do that if it's something divided by itself with like all wrapped up and real nice. This one is all loose and wiggly. We need to factor these pieces before we can do any canceling to the problem. So looking at the top one, we do have an x squared and a y squared in common. In terms of the 15 and the 14, there's nothing we can really factor out. So we can factor out an x squared and a y squared. And we're left with negative 15y plus 14. And then in the bottom, we again have, did I miss a squared? No, I did not. Okay, on the bottom, we've got a y and an x squared and a y. And you know what I'm also going to do is because see how these are opposite signed? We've got positive and negative, negative and positive. I'm also going to factor out a negative. That way I can switch the signs. Maybe these will match. I don't know. Or I could just be wasting our time. Who knows? So this is going to be negative 15. Yep, I'm wasting our time. XY. And then the other one is plus 14. So in terms of what we can cancel these two x's, those are gone. We can cancel this y and that squared, but that parentheses, it's just a little bit, geez, that x, unless I missed something somewhere, yeah, just that x is just ruining our day. Oh well. So y prime, what are we doing here? Y prime equals y times negative 15 y plus 14 over, let's see, negative 15y plus 14. All set. So, bit of a mess, but yeah, whatever. It's y prime. Sometimes things are a little messy. Okay. Next, we're going to factor some binomial and trinomials. This is just more factoring stuff, which I am going to cut because I think this video has been going long enough as is, and these are just regular factoring stuffs. So I'm just going to jump to our finisher. Just remember TLDR, a bunch of things that we talked about is intercepts. Those solutions that we were coming up with, those were intercepts to all of those things. So I kept saying, well, what does x equal? Those solutions are intercepts. Zeros, solutions, all the same thing. Your steps for factoring are factor out your GCF, difference of squares, sum and difference of cubes, which we didn't see an example of, but they're pretty self-explanatory, and then just factor as two binomials. So thanks for watching your video. Once again, you want to move on to that check for understanding where you do a couple problems that are like what I did in this video to see how well you understood everything. Thanks for watching. Bye-bye.